What's up, guys? My name is Michael and welcome to my YouTube channel. So today we're going to talk about implementing inheritance. So just like last time, during the design, the objects and all that other stuff from last time, this time we're going to implement it. So what is inheritance? Well, today we're going to learn about what the nature of inheritance is, how to use inheritance to drive one class to another, what protective access is and how to use it, and what virtual functions are. So what exactly is inheritance? Well, remember last time we talked about specialization, like creating an animal and then a dog as an animal. Well, basically inheritance is you create your base class, such as the animal class, and then the dog inherits every code of the animal class, like all the code, all the attributes of the animal class, and this prevents like rewriting code and stuff like that. So what is inheritance? When you look at your pet, what do you see? Some people see 4 legs, so, and a taxonomer sees a representation of the canine domestic. So this specialization hierarchy symbolizes this is a relationship. A Homo sapien human is a kind of primate. This relationship can be seen anywhere. A station wagon is a type of car, which is a kind of vehicle. A Sudan is a kind of dessert. Oh, a sundae, my bad. A sundae is a kind of dessert, which is a kind of food, and stuff like that. So because it's a specialization of something, you could write the class, the code for that first, and then later inherit everything else with your whatever object that is a specialization of it. So inheritance and derivation, it's basically the dog inherits all the features of a mammal, and therefore you could write all mammals by definition move and breathe air. So then basically the dog inherits all the code of the mammals, but then also the dog adds the idea of barking, wagging its tail, eating revisions to the chapter when he's done, and barking and when he's trying to sleep. So yes, you could add more code onto the dog, but you also inherit everything of the mammal class. That's what basically inheritance is. So you could divide the dog into working parts of the dogs and canines. You could divide the sporting dogs into retrievers and so forth. And these are specialized even further. So C++ represents these that enable you to define classes that derive from one another. The derivation is a relationship, so we already talked about that. So here look at the hierarchy of animals. Mammal is a type of animal, so all these inherit the code of animal. Horse and dog inherits everything of mammal. Working, sporting, terriers inherit all the code of dog. Retrievers and spaniels inherit all the code of sporting, and Labradors and Goldens inherit all the code of retrievers. So, the animal kingdom. To facilitate the discussion of derivation and inheritance, this chapter focuses on the relationships among a number of classes representing animals. You can imagine that you have been asked to design a child's game, a simulation of farm. So in time, you'll develop a whole set of animals, horses, cows, and stuff like that, and you create methods for these classes. So stubbing out methods means you'll only write only enough to show what the function was called, leaving the details later when you have more time. So feel free to extend the minimum code in today's lessons, such as that. So you could find examples using mammals. You could find easy, for example, you're building ADTM. Okay, so the syntax derivation. When you declare a class, you can indicate what the class it derives from by writing a colon after the class's name and the type of derivation, public or otherwise, and the class which it derives. So you write your class's name, and then you write class, then your class's name, and then the colon, and then the access type, and then the base class. So if you want to inherit all the code of the mammal class, all you do is you write. If you want to inherit all the code of the mammal class in your dog class, all you do is write. When you declare your class for your dog, you write class dog and then colon. Then you do public and then mammal, because that's the code you're inheriting it from. This type of derivation is discussed later in today's lessons. For now, always use public. The class from which you derive must have been declared earlier, or you receive a compile error. So yeah, if you don't have the class defined earlier, like mammal, then you can't inherit it. So that's why it has a compile error. That's what occurs. So to declare a dog class as inherited from the mammal class. So I'm actually not gonna type this up for now, but this is what I'm going to do. I'm going to explain what it does. So they have an enumeration breed, which is just basically an enum type, which is just another name for constants, remember? So this has, I think it's 1, 2, 3, 4, 5, 6. So Golden is the value 1, Karen is a value 2, Danny is a value 3, Shetland is a value 4, Doberman is a value 5, and Lab is a value 6. So these are just another, they just replace the names of these things with numbers. They're just numbers, okay? So then they have a class called Mammal, and then they have constructors, Mammal, constructor, the destructor for Mammal. They have the get age, set age, get weight, and set weight, and these are all accessors, and they have other methods such as speak and sleep. And then they have these protected instance variables, its age and its weight. We'll go over that later. So basically, and then they have the dog class that inherits all the code from the mammal class. So the dog class has the dog constructor, the dog destructor, but they also, because they inherit the stuff from the mammal class, they have the value of breed. So in here, you see that it returns a breed, which is just a constant, right? It's just a number, right? So then they have, because it's an enum, right? It's a constant, it's a number. These are just numbers 1, 2, 3, 4, 5, 6. So they have a method called getBreed, and it's a constant method. That means it doesn't modify any of the instance variables, and it just returns the breed. And then they have a setBreed, and then they have other methods such as Wagtail, beg for food, and they have a protected instance variable called the breed, and its breed. So they have an instance variable that is one of these types of breed, okay? And it's just a number because it's an enum. So this program has no output because it is only a set of class declarations without their implementations. Nevertheless, there's much to see here. So on lines 7 to 28, the mammal class is declared. See, 7 to 28, this whole thing is the mammal class is declared. And note that the mammal class does not derive from any other class. So it's just a regular class. In the real world, mammals do derive from other classes because mammals are the type of animals. But in the C++ program, you can represent only a fraction of the information you have about any given object. Reality is far too complex to capture all of it, so that's why this hierarchy is only, it's a small hierarchy, okay? It's just the dog inheriting the code from the mammal class, okay? So the mammal is not inheriting any other code, so that's why it's not really, it's just by itself. That's what it is. Because you can't represent all of the stuff of what a mammal is. So that's why it's saying that there. So reality is too complex for it. Hierarchy has to begin somewhere, so this program begins with a mammal. Because of this decision, some member variables might properly belong in the higher base class are not now represented here. So certainly all animals have age and weight, and so forth. Mammal is derived from the animal, so you could expect to inherit those as it is. So in the future, this is how hierarchy is. Okay, so to keep program reasonably simple, only 6 methods have been put in the mammal class: the 4 accessors and speak and sleep. So the dog inherits everything from mammal, as shown in line 30. You see here, line 30, with the colon, this inherits everything from mammal. Okay, so the dog you know that the dog inherits from mammal because of the colon, and then followed by the base class name. So yeah, that's what happens. Every dog object will have 3 member variables: its weight, its age, its weight, and its breed. Okay, so here you don't see the instance variables of it. You only see its breed here. That's in the dog, but it actually inherits everything from mammal. So mammal has its age and its weight. So because the dog inherits everything from mammal, the dog has all the things from mammal plus the new instance variables defined. So mammal has its age and its weight, right, as instance variables. So the dog class also added its breed. So the dog currently has 3 instance variables. Has the ones from the 2 from the mammal class, which is its weight and its age, and it has the one from its breed. So it has 3: its age, its weight, which is 2 integers, instance variables, and then its breed. Okay, so that's what it talks about. It has its age, its weight, and its breed. Note that the class declaration of dog does not include the member variable, its age, and its weight. Okay, yeah, so we know the dog has those values, but it inherited all the variables from the mammal class, along with all the mammals methods except the copy operator and the constructor and destructor. So it inherits all the mammals methods except the copy. So here we see mammal, it inherits everything. So all these methods except the constructor of mammal, as you can see here. Yeah, so it inherits everything except the copy operator and the constructor and destructor. So dog inherits everything except for the constructor and destructor, as well as a copy operator. But there's no copy constructor here, so that's why. Okay, so let me see. Private versus protected. You might have noticed that a new access keyword protective has been declared on lines 25 and 46. You see here, 25 and 46, 45 and 46 protected, and protective 25. Okay, so now we're going to explain what protected is. Previously, the class data have been declared private. However, private members are not available outside of the existing class. This privacy even applies to prevent access from derived classes. You could make it its age and its weight public, but that is not desirable. You don't want other classes accessing these data members directly. So, previously, remember, we created private so that other people can't access the whatever variables and stuff like that. However, private members are not available outside the existing class, and the privacy even applies to prevent access from derived classes. So if these were private, then what would happen is that you can't inherit them. Like for these, you can't inherit any of them. The private protects it from inheriting all the other things. So that's why they didn't put private here. But they don't also want it to make it public, so because if they make it public, then everyone has access to it. So that's why currently they made it protected. So we're gonna explain what protected is. What you want is the designation to say make these variables visible to this class and the classes that derive from this class. This designation is protected. Protected data members and functions are fully visible to derived classes, but are otherwise private. In total, 3 access specifiers exist: public, protected, and private. If a function has an object in your class, it can access all the public member data and functions. The member functions in turn can access all private data members and functions of their own class. So, if a function has an object in your class, it can access all the public members. Yeah, okay. The member function in turns can access all private data members and functions of their own class, and all protected data members and functions of any class which they derive. So, if the dog, inside dog, it could access anything. Well, inside dog, it could access anything that's like everything that you declared here. Like if you created a method, right, in dog, well, it could access anything that you created in dog. Well, that's just obvious, right? Like dog thing, get breed, set breed. If you create a method, anything, it could access all these things, including the private and the protected. But if you're outside of that, you can't really access those things. So we're gonna just talk about what that is. So if a function has an object of your class, it can access all the public member data and functions. The member functions in turn can access all private data members and functions of their own class. Yes, and all protected members from any of the classes which they derive from. So the dog can access all the things that protected things that are derived from mammal, as well as the public things, but not the private ones. So here, all these things are public, so the dog derives everything, gets all the code from here. But they also get the protected ones, right? Derived from mammal. So yeah, that's what it means. So that's the function Wagtail can access private data, its breed, and can access the protected data, its age, and its weight in the mammal class. So yes, in Wagtail, it could act because even though Wagtail is private, like if you don't put the thing, we know it's private, right? So other people can't access this method if you create a dog, right? And they can't access it. But inside the dog class, the Wagtail can actually access anything in the dog class. Like that just makes sense, right? Like in your class, you could access other things in your class, right? It just makes sense. So the Wagtail can access all the public things in the dog, even the private ones, right? In the class, it could access like the private methods such as beg for food and the protected methods. So that makes sense because it's in the class. Like your private isn't private. If it's private, you could still use it in your class. You just can't use it like other people outside trying to get your code. They can't look at it. Right? As in like if I create dog X equals new dog, right? Well, the new dog, if I'm not in this class, I can't have access to Wagtail. But in Wagtail, like if in the dog class, if I have this private method Wagtail, it could access all these things, as well as all the things in Mammal, the protected and the public data in Mammal. So that's what it's talking about. Even if other classes are layered between Mammal and Dog, for example, the Dog class will still be able to access the protected members of Mammal. Yes, assuming that all the other classes all use public inheritance. So private inheritance is discussed later. So this demonstrates the create objects of type dog and then how to access them. The dog, they created a dog Fido, right? And then the dog is just a dog object. So what they're going to do is they're going to call speak. So in the dog, there's a speak. There's no speak, right? You know why? Because speak was inherited by Mammal. So in here we say speak. And the reason why it's able to call speak is because all the code of the method speak was inherited by Mammal. It's in Mammal. That's why I was able to call it. So then output said Mammal sounded. So yes, because it printed out the Mammal sound. So that's why the first output is Mammal sound. Then they did Wagtail. So then they called Wagtail. Well, Wagtail, where is Wagtail? Well, Wagtail is actually in the dog class, right? So then they print out tail wagging. So that's why it printed out tail wagging. Then after that, they printed out the age, and then they printed out the dog's age. So where is the dog's age, right? So the dog's age is actually in the Mammal class. So they returned the age in the Mammal class. So that's why the age is 2 years old. And the reason is that the Mammal class is declared. Here, the dog class is declared and as derived as a class of mammal. Thus, by these declarations, all dog has an age, a weight, and a breed. As stated before, the age and the weight come from the base class mammal. So when the dog is declared, Frito inherits all attributes of the mammal as well as all the attributes of the dog, and it knows how to wag its tail and knows how to speak and sleep. So the Frito calls 2 of these methods from the base class, and it is called successfully. So the reason why is because in the dog's constructor, right? It's we'll go over constructors now. Okay. So inheritance with constructors and destructors. So the dog objects are mammal objects is essential as a relationship. When Frito is created, his base constructor is called first, creating a mammal. Then the dog constructor is called, completing the construction of the dog object. Because Frito is given no parameters, the default constructor was called in each case. So here, we saw Frito has no parameters. So in here, it called the dog's classes of its default constructor, right? So, but the thing is that when Frito is created, his base constructor is called first. So it calls the mammal constructor first, and then and the mammal constructor, because it's the base class, and that's its age and its weight. So then that's why it called that, and that's the reason why it was able to initialize the age and its weight, because in the dog class there was actually no age and weight, but it inherited everything from here. So it called the default constructor in each case. Frito doesn't exist until he has been constructed, which means that both his mammal part and his dog part must be first constructed. Thus, both constructors must be called. So what happens is the base constructor is called first, and then the dog constructor is called, completing the construction of the dog object. So it first calls the base constructor, which is this, and then it calls the dog's constructor. So that's why. What else? Yeah. So when Frito is destroyed, the first dog destructor is called, and then the destructor for the mammal part of the Frito is called. So each destructor is given an opportunity to clean up after its own part of Frito. Remember to clean up your own dog. So this demonstrates what happens. So basically, after when you create a dog object, it first calls the default constructor of the mammal, because it's derived. It's the class inherited from. So they called mammal's constructor, and then after that they called the dog's constructor. Then after everything the dog's done, it calls the dog's destructor, and then it calls the mammal's destructor. So it goes the other way. So here it prints out mammal constructor, then it's dog constructor. Then they printed out mammal sound. So they called the Frito.speak, right? And then Frito.speak is in, let me see, Frito.speak. Speak is mammal sound, yeah. So they called a method in the mammal class, right? And then after that, they called the tails wagging. They called tails wagging, which is Wagtail, which is in the let me see, yeah, it's in the Wagtail. Oh, that's in dog, yeah. So it printed out Wagtail, right, which is the method in dog. And then after that, they print out Frito is this amount of years old, and because it was initialized in the mammals constructor, Frito's age is printed out to be 3 years old. And then they call the dogs destructor and then the mammals destructor. So the constructors and destructor are now part of the screen, and the mammals constructor is called then the dogs. So when Frito goes out of scope, the dogs destructor is called, followed by a call to the mammals destructor. You see that this is confirmed in the output from the listing. So now, passing arguments to base constructors. It is possible that you want to initialize values in a base constructor. For example, you might want to overload the constructor of mammal to take a specific age and want to overload the dog constructor to take a specific breed. But how do you get the age and mammal parameters passed to the right constructor in mammal? What if dogs want to initialize weight and mammals don't? So base class initialization can be performed during class initialization by writing the base class name followed by the parameters expected by the base class. So here we see you could write the base class initialization by writing the parameters performed by writing the base class name and followed by the parameters expected by base class. So here we see what they did here is that they just had their own overloaded constructors, mammal, int age, and then they had dog constructor, int age, int weight, int age, int breed. So yeah, so these are just overloaded constructors. And then how they call it was they called it through and so in the dog constructors they overloaded it by having an initialization block of here in the mammals, right? But in dog to call it they just did what did they do? Oh yeah, they just called mammals constructor by putting a colon and then mammal and passing it in age. So that's the way that you call the base classes constructor, the right one that you want to pass in. So here it showed it. Listing the mammals constructor can be overloaded on line 12 to take an integer, the mammal's age. The implementation on lines 62 to 67 initializes its age with the value passed into the constructor and initializes its weight with the value 5. So dog has overloaded 5 constructors. The first is the default constructor, then the 37 takes the age, which is the same parameter that the mammal constructor takes. The third constructor takes both the age and the weight, and the fourth takes the age and the breed. So the code for the dog's default constructor, you can see this has something new. When the constructor calls, it is in turn calls the mammal's default constructor, as you can see in line 75. So in line 75, it calls the mammal's default constructor. See, all you have to do is put a colon and then call whatever constructor you want. So it calls the mammal's default constructor, and let me see. So the constructor is called, and it calls the mammal's default constructor, as you can see in line 75. Although this is not necessary to do this, it serves as documentation that you intended to call the base constructor, which takes no parameters. Base constructor would be called in any case, but usually actually doing so makes your intentions explicit. So the base constructor normally calls it anyway, regardless of what you write over there. So that's what happens. The implementation for the dog constructor, so which takes an integer in lines 81 to 86. The initialization phase lines 81 to 82 to 83, which is over here. It actually calls the initialization there's a comma that has its breed, and it calls the initializes the variable of its breed to gold. Let me see. Note that you don't have to assign the base class variable in initialization phase because the mammal does not have a constructor that takes this parameter. You must do so in the body of the dog's constructor. Okay, so yeah. Walk through the remaining constructors and certainly you will be comfortable how they work and how they initialize. The output has been numbered so that each line can refer to analysis. The first two lines of the output represent the instantiation of Frito using the default constructor. So in the output, lines 3 and 4 represent the creation of Rovert, and lines 5 and 6 represent Buster. Note that the mammal constructor that was called the constructor takes one integer, but the dog constructor is a constructor that takes two integer. After all the animals are created, they are used and then go out of scope as each object is destroyed. The first dog constructor and then as each 5 and 2. Okay. Alright guys, so now we're going to talk about overriding base class functions. So the dog object has access to all the data members and functions in the mammal class. But what if you want to change the implementation of a mammal class? Like you want to override the base class function. So overriding a function means changing the implementation of a base class function in the derived class. So when a derived class creates a function with the same return type and signature as a member function in the base class, but with a new implementation, it is said to be overriding that function. So when you make an object of the derived class, the correct function is called. When you override a function, its signature must agree with the signature of the function in the base class. So yeah, that makes sense. The signature is a function prototype other than the return type. That is the name of the function, the parameter list, and the keyword const. If used, the return types might differ. So here they have the base class, overriding a base class method in the derived class. So here mammal has the same things that we had before, but instead the dog is going to change something. Instead of when it speaks, instead of saying I'm sleeping, instead of saying mammal sound, the dog is going to now change to wolf. So when it speaks, when you call mammal big animal, dog Fido, when the mammal speaks, the mammal is going to the big animal, which is a mammal, right? The mammal is gonna say, okay, I'm gonna call the mammal sound, right? So in mammal, it's going to say, when it speaks, it says mammal sound. So over here, it's going to say mammal sound, and then over here, when Fido speaks, the dog, instead of saying mammal sound, it's going to say dog sound, right? So here, you see in the output that you also, when you create objects, they call the mammal constructor, right? So it calls a mammal constructor. Then when it creates the dog, it's going to call the mammal constructor as well, because the dog, in the dog, it's going to call the mammal constructor, and then it's going to call the dog's class constructor. So it's going to call mammal constructor and then dog constructor. So mammal constructor, dog constructor. Then over here, big animal dot speak, because big animal is a mammal, it's going to say mammal sound. So that's what it does. Then when Frito speaks, it's going to say wolf, because he changed the implementation of the speak in the dog class by overriding it, by having the same name and same signature. Instead of saying I'm sleeping, it's going to say, it's going to say wolf. Instead of saying mammal sound, it's going to say wolf. Yeah. So it's going to say wolf. Then it calls the dog destructor and then the mammal destructor. And then, afterwards, after it calls the dog destructor, mammal destructor, this big animal, the mammal big animal, calls its destructor as well. So that's why the last one's a destructor. So looking at the mammal class, you can see the speak defined on line 15. Dog class declared in 23:37 inherits the mammal class. Therefore, has access to the speak method. The dog class, however, overrides this method, causing the dog's object to say wolf when the speak is called. In the main function, the mammal object big animal is created in line 41, causing the first line of output when the mammal constructor is called. On line 42, a dog object Frito is created, causing the two lines of input. So it's these two, when it calls the dog, right? When you create a dog, because it inherited the mammal, it's going to call the mammal's constructor first, then it's going to call the dog's constructor. So that's why. For the dog, like see dog Frito, it's going to call the mammal constructor, then the dog, because mammal overrides mammal was from the dog. Like, yeah, that's why. Yeah, that's why. It's not the it's not overriding. It's the because of the derived class. Mammals comes with dog. So yeah, and the main function is in the dog Frito causing the next two line where mammal constructor and then a dog constructor is called. On line 43, the mammal object calls its speak function method. Then on line 44, the dog object calls speak. So the output reflects what the correct methods are called. The big animal made a mammal sound and the Frito wolfed. Finally, the two objects go out of scope and the destructors are called. So overloading versus overriding. These terms are similar, but they do different things. When you overload a method, you create more than one method with the same name but different parameters. When you override a method, you create a method in the derived class with the exact same name and the same methods, the same parameters. So that's the difference. In overloading, you change the parameters, right? In overloading, in overriding, you don't. Overriding is the exact same signature. Okay. Hiding the base class method. So in the previous listing, dog's class speak method hides the base class's method. That is what it wants but it can have unexpected results. So in the dog's class, right? In the dog's class speak, right here, it hides the implementation of the the base class's method, but it can have unexpected results. If mammal has a method move, which is overloaded, and a dog overrides that method, the dog method hides all the mammal methods with that name. So if mammal has a method move, right? So let's say mammal had a method move. It is overloaded, so that means there's more methods of move. Right? It's the same name of move, but different parameters, right? But the dog hides it by creating its own thing. Then the dog hides all the mammal methods with that name. That makes sense, though. Yeah. If mammal overloads move as three methods, one that takes no parameters, one that takes an integer, and one that takes an integer and a direction, and dog overrides just the move method that takes no parameters, it will not be easy to access the other methods using the dog object. Okay. So here, they created two moves, right? One is that takes in a distance, and the other one just takes in nothing, but it prints out mammal move on one step. They have another one that takes in a distance and prints out mammal move and then the distance steps. So if the dog overrides this by creating its own move method, calling move is harder because you might have unexpected things. Because they overwritten the move method in mammal, this move method, it also overwritten this method. So when you have overloaded things with the same name and you overrided this, calling this might be a compile error. So we're actually going to try this right now. So there's actually a compile error when you try to call the move method with the parameter. Because what happens is that, you see, because since mammal has two overloaded methods, right, of move, right, but then dog inherits them all, right, but then you overwritten the move method by creating your own. So now this implementation is what it's called for dog, right? So then because you did this, you can't actually call the mammal's move method for their distance. See? Even though you didn't override the move method that takes in a parameter for distance, you can't call it anymore. It doesn't allow you to. So when you override one method with the name of move, it actually overrides, like, it doesn't let you do any other methods, and it overrides the other ones. So rule is if you override any overloaded method, all the other overrides of all those methods are hidden. If you want them to not be hidden, you must override them all. Okay, so that's what happened. Yeah. Okay, so if you want to use this again, so all the move method is hidden. If you want to use the move method, you have to override that for dog. For this move method, the one that takes in the distance, You have to override it in here. Otherwise, you can't do that. So, otherwise it hides the method that doesn't override. This is reminiscent to the rule you supplied if you supply any constructor, the compiler no longer supplies a default constructor. So the rule is this. After you override any overloaded method, all the other overrides of that method are hidden. If you want them not to be hidden, you must override them all. It is a common mistake to hide a base class method when you intend to override it by forgetting to include the keyword const. Const is part of signature. Leaving it off changes the signature, thus leads the method rather than overrides it. So you have to put const as I have the exact same thing. So later on, virtual methods are described. Overriding a virtual method supports polymorphism. Hiding it undermines polymorphism. Okay, so calling the base method. If you have overwritten the base method, it is possible to call it by fully qualifying the name of the method. You do this by writing the base name followed by 2 colons and then the method name. So you put base class colon and then method name. Okay, so if you call the move method a mammal class, you could do this as followed. So if you've overwritten the base method, you could still call it by doing mammal colon move. You can also use the qualified names just as you would as any other method. It would have been possible to have rewritten the lines so that it would compile by writing Frito.mammal colon move. This calls the method explicitly. So, okay, so yeah. Here, let's just see what it does. This is the same code, I think. Okay, so if I want to call Frito move, right? But I've overwritten the move method in the dog. I could still call the mammals. Mammal move. Oh, it has to be Frito. No, wait, no. You could still call it by doing, what was the syntax? Mammal colon move. So Frito.mammal colon move. Frito.mammal. Wait. Frito's undefined. Oh, Frito. Yeah, okay, so that works. And you could also do Frito.mammal colon move like that. So this should have the same values as before. These two should have the same values. Well, though, this should be 2. So, as you could see here, let's just see what happened. Mammal move 1 step. Yeah, that makes sense because mammal moves 1 step. Then mammal moves 2 steps. Yes. Freedom. Mammal moves 1 step. Yeah. Because even though it's a dog, I called the mammals method a move. Yeah, so that's why it says mammal move 1 step, mammal move 10 step. Yeah, because even though I overwritten it, I could still call it by doing Frito.mammal colon move. Okay, so this calls the mammal method explicitly. This illustrates the idea. So yeah, that works. Program might want to invoke move on the dog object, but had a problem. The dog overrides the move method, but does not overload the method that takes an integer. It does not provide a version that takes an integer. This is solved by explicitly calling the base class move method on line 37. So, on line 37, you could explicitly call it by doing Frito.mammal move. So even though the dog object overrides the move one with no parameters, it doesn't overload the method that takes an integer, right? It doesn't override that. It doesn't provide a version that takes an integer. So in order to do that, you have to explicitly call yourself Frito.mammal. So yeah, then that would work. When you're calling overwritten ancestor class methods using the colon, keep in mind that if a new class is inserted in the inheritance hierarchy between the descendant and its ancestor, the descendant will now be making a call that skips past the intermediate class and therefore might miss invoking some key capable and implemented by immediate successor. Okay, yeah, it's saying that if you make sure you use the colon, because if there's an ancestor between the two things, it might skip past the capabilities. Okay, so now we're going to talk about virtual methods. This lesson emphasizes the fact that a dog's object is a mammal object. So far, that only meant that the dog object has inherited the attributes and capabilities of the base class. In C++, there is a relationship that is deeper than that. C++ extends its polymorphism to allow pointers to base classes to be assigned to derived class objects. Thus, if you write the mammal p mammal equals new dog, this creates a new dog object on the heap and returns a pointer to that object, which is assigned to a pointer to mammal. This is fine because the dog is a mammal. This is the essence of polymorphism. So because the dog is a mammal, you could create mammal p mammal equals new dog. You can use this pointer to invoke any method on mammal. What you would like is for those methods that are overwritten dog to call the correct ones. Virtual methods enable you to do that. So you can then use this pointer to invoke any method on mammal. So because you have p mammal, right, you could invoke any method on mammal. But you would also like to, for those methods that are overwritten in dog, to call the correct function. So virtual methods allow us to do this. To create a virtual method, you add the keyword virtual in front of the function declaration. This illustrates how it works, and what happens with non-virtual methods. Okay, so I'm going to look what happens when I ran the code. So because a dog is a mammal, you could do mammal star p dog equals to new dog. What this did was it allocated memory on the heap for a pointer to a object of a new dog, right? Because dog is a mammal, you could do this. Then when they do p dog dot move, right? When you do p dog dot move, right? Ideally, this should do the dog's move, right? But it doesn't. It actually does the mammal's move over here. It does mammal move one step because it calls the base class's move method, right? Mammal moves one step. So to fix this, what they did was they made p dog when you do speak, right? They called to call the right method for speak. They made it virtual. See, they made this virtual. So then when mammals speak, when you do p dog dot speak, right? P dog arrow speak, that actually calls this speak wolf, and that's why over here it says wolf. Let's just continue reading. So mammal is provided in a virtual method. So by putting virtual, it helps it. The designer of this class thereby signals that she expects this class eventually to be another class's base type. The derived class will probably want to override this function. So that means that this class expects to be another base class, and the derived class would want to override the function. In line 29, a pointer to mammal is created p-dog, but it is assigned the address of a new dog object. Because a dog is a mammal, this is legal. Right, if you do p mammal equals to new dog, no, if you do, so this is legal because a dog is a mammal. A dog is a mammal, right? But if you did dog p mammal is equal to new mammal, that won't work, okay? Because a mammal is not a dog. So that's why this works. So a pointer to create a p-dog, but it is assigned the address of a new dog object. Because the dog is a mammal, this is a legal assignment. The pointer is then used on line 30 to call the move function. Because the compiler knows p-dog only to be a mammal, it looks to the mammal object to find the move method. On line 10, you could see this as a standard non-virtual method, so the mammal's version is called. So yeah, it looks to the mammal's object to find the move method. Because it found the move method, that is called. Yeah, but then what they did, so to fix this, they put a virtual in front of speak to make sure that it calls the dog's version. So here to make sure it calls the right version, they put virtual in the mammal class for the speak, so then it calls the speak for the dog version for wolf. So yeah, because speak is virtual, the speak method overwritten in dog is invoked. This is almost magical. As far as calling functions go, it has a mammal pointer, but here a method on dog was called. In fact, if you had an array of pointers to mammal, each of which pointed to a different subclass of mammal, you could each call in turn and the correct function would be called. Okay. So here, what they did was they had an array of mammals, right? And because the thing is virtual for speak, it would automatically call the right method for whatever individual class that overwritten this method. So here they had like cat, horse, all these things overwritten the method speak. So because in mammal it's virtual, all of them display the right speak. Like for pig it's oink, and like for horse it's whinny, and for cat it's meow. So they had all that right. This provides a basic functionality for online speak is declared to be virtual. Yes. So all these things overwritten the implementation of speak. It is impossible to know what objects will be created, and thus the speak method will be invoked. The pointer PTR is bound to its object at runtime. This is called dynamic binding or runtime binding, as opposed to static binding or compile time binding. So the program loops through the array again, and then it calls a speak for each thing. So you can see the output that if you choose a different type, the correct method was invoked. So if I mark a class method as virtual in the base class, do I need to mark it as virtual in the derived class? No, because once a method is virtual, if you overwritten in the derived class, it remains virtual. It is a good idea to continue to mark it virtual. This makes the code easier to read though. So how virtual functions work. When a derived object such as a dog object is created, the constructor for the base class is called, and then the constructor for the derived class is called. So this shows what the dog object looks like after it is created. Note that the mammal part of the object is continuous in memory with the dog part. So this is what happens after the dog object is created. The mammal part, and then it's mammal, and then the dog object, and it's dog. When a virtual function is created in an object, the object must keep track of that function. Many compilers built a virtual function table called a vtable. If one of these is kept for each type, and each object of that type keeps a virtual table pointer called a vptr or a vpointer, which points to that table. Although implementations may vary, all compilers must accomplish the same thing. Each object's vpointer points to the vtable that in turn has a pointer for each of the virtual functions. So when the mammal part of the dog is created, the virtual pointer is initialized to point to the correct part of the vtable, as shown in here. Oh, okay, so they point to the right one. When the dog constructor is called and the dog part of the object is added, the v pointer is adjusted to the virtual function that is overwritten in the dog object. So you see it points to the right one. So when a pointer to an animal is used, the v pointer continues to point in the correct function. Thus, when speak is called, the correct function is invoked. Okay, so trying to access methods from a base class. You have seen methods accessed in a derived class from a base class using virtual functions. What if there's a method in the derived class that isn't in the base class? Can you access it the same way you have been using the base class to access the virtual methods? There shouldn't be a name conflict because only the derived class has a method. If the dog object has a method, Wagtail, which is not in mammal, you could not use the pointer to mammal to access that method because Wagtail is not a virtual function. And because it is not in a mammal object, you can't get there without either a dog object or a dog pointer. You could cast a mammal to act as a dog, however this is not safe if the mammal is not a dog. Although this would transform the mammal pointer into a dog pointer, a much better safe way exists to call Wagtail method. Besides, C++ frowns on explicit casts because they are error prone. The subject is addressed in full detail in multiple inheritance covered on day 15 and when templates are covered. Slicing. Note that virtual function magic operates only on pointers and references. Passing an object by value does not enable to the virtual function to be invoked. Ooh. Okay. So when they do call it, if you do 1, it calls wolf wolf and then it calls mammal speak. If you do 2, it calls meow meow and mammal speak. So what actually happened was, let's see what happens. If you do 1, right, created a new dog object, right, and then it breaks, then it passes in that dog object into PTR, right, in a PTR function, and then it passes the reference and then the value function, right. So in PTR function, they all call the speak, right? Okay, so all these functions call the speak. But what happens when you do case 1, right? So when you do case 1, and you pass it in by the pointer to the function, if you just pass in the regular function and you call speak, it calls wolf. Okay, like if you pass in the mammal, the dog into the mammal, it calls wolf. Okay, so that it calls the virtual one. When you pass it into the pointer, it calls wolf. But if you pass in by reference, it calls the mammal version of speak. Okay, so that's the same thing here. So the user prompted is the choice is made. It shows the dog. The dog is created on the first free store. The dog's passed in the point and then by reference and by value. The pointer and reference calls will invoke the virtual function the dog speak member is invoked. This is shown in the lines of the user thing. The dereference pointer, however, is passed by value to the function on lines. The function expects a mammal object, and so the compiler slices down the dog object to just the mammal part. When the mammal speak method is called, only the mammal information is available. The dog pieces are gone. This is reflected in the third line of the output after the user's choice. This effect is called slicing because the dog portions of a derived class were sliced off after converting just a mammal class, the base class. This experiment is repeated with the cat object with similar results. So over here, what happened was when they passed in the value function over here, when they passed in by value, it actually stripped away all the thing for the mammal. Because it was casted to a mammal, it called the mammal method of speak. It didn't actually call the right one, the right method for speak. Even though for the other ones, for pointers and for reference, for pointer and reference, they called the right methods for speak, but for the passing by value function, it did not. Even though the speak method is virtual. That's what happened. Because the dog object were sliced off to convert to a mammal. Okay, so creating virtual destructors. It is legal and common to pass a pointer to a derived object when a pointer to a base object is expected. But what happens when that pointer to a derived object is deleted? If the destructor is virtual, as it should be, the right thing happens. The derived class's destructor is called. Because the destructor's class's destructor automatically invokes the base class's destructor, the entire object is properly destroyed. Okay, so the rule of thumb is this. If any of your functions in your class are virtual, the destructor should be as well. You should notice that in the listings of today's lessons, there are virtual destructors. Now you know why. It is general. It is wise to make virtual destructors virtual. So the reason why you have destructors is that what happens when the pointer to a derived object is deleted. If the destructor is virtual, then the derived class's destructor is called, right? But if it's not, then it would invoke the base class's destructor. So the entire object is because the destructor invokes the base class destructor, the entire object is probably destroyed. Because the derived class's destructor automatically invokes the base class's destructor, the entire object is destroyed. Okay, so here's what happens. So constructors cannot be virtual, and so technically there's no such thing as a virtual copy of constructor. Nonetheless, your program desperately needs to be able to pass a pointer to a base object and have a copy of that correct derived object that is created. A common solution to this problem is to create a clone method in your base class and make it that virtual. So, the clone method creates a new object copy of the current class and returns that object. So because each derived class overrides the clone object, a copy of the derived class is created. So this is shown how the clone method is used. Okay, so here it's the same thing as the other one. This time for the clone method, they created a clone method that casts that returns the new constructor. Alright guys, so basically it's the same thing as before. The difference is that this time they created a virtual copy constructor. So what is a virtual copy constructor? It's just the same thing as a constructor. So for the mammal, they made it virtual. All right, they made a mammal thing virtual that has clone. So the reason they did this is that in the other copy constructors that implement this copy constructor for anything that inherits this code, right? They would return, if it's virtual, it would call the right one. Okay, it would call the right one. For virtual mammal clone, right? This returns the pointer to this object, which makes sense because what it's doing is it's just cloning the pointer for the current object, right? So then when for the other ones clone, they call the return a pointer to the cat, and they return a pointer to the dog and then they return a pointer to the other ones. So the reason why it's a pointer is because it's the method returns a pointer to the new object by calling the copy constructor, is because they return new cat, or not new cat. For virtual in mammal, they return new mammal, and this calls the mammal's copy constructor over here, which is where is it? Yeah, right here. The mammal's copy constructor, and they pass in the current object into the mammal's copy constructor. So star this is the data at this. So then this returns a copy of the mammal, right? Okay, it returns a copy of a mammal, and it returns the reference, the pointer to it. So because this is virtual, right? Anything that implements this is going to have to implement this, right? Because it's virtual, it's going to call the right one for the other ones. So if it's a dog, it's going to call the right virtual clone. So when they overwrite virtual mammal clone, for the dog they return the dog's copy constructor by passing in this. So then because it's virtual, when you call the mammal pointer mammal equals to new dog, and then you call the clone method, the copy constructor of mammal, it calls the right copy constructor with the clone. So that's what happens. So when you do one, right, a mammal goes to here. So first it does, if you do choice one, right, dog, right, the pointer points to a new dog, right, but the pointer is a mammal, right? So the pointer is a type mammal. It points to a new dog. So what does it do first? Well, it goes to the mammal's mammal's constructor. That makes sense because the dog inherits the mammal, all the code for the mammal, so it does the mammal's constructor first. So what is in the mammal's constructor? Well, in the mammal's constructor, it prints out, it initializes its age to 1 in this initialization area, and then it prints out mammal's constructor. So that's what they do here first. That's the reason why the first one is mammal constructor. Then after that, after the mammal constructor is called, it calls a dog's constructor, because a dog is a mammal and it inherits all the things for the mammal. It calls the mammal's constructor, and then it calls the dog's constructor, right? So then it goes to here and it goes to the dog's constructor, and it prints out dog's constructor. Okay, and that's the reason why the second one is dog constructor. So and then when you type in 2 for the cat, right, it does the mammal constructor and then the cat constructor. When you do 3 for the mammal, it does the mammal constructor, right? And then right here it does the mammal constructor, right? And then it breaks, right? And then it calls the for mammal constructor, it breaks. Okay, and then after that it calls the it says the array pointer to point to that. It creates an array, and then it calls each individual speak, and then does a clone. Okay, so then it creates a copy for each one, and then when it calls it speak, it does the right one for each one. So for the mammal copy, it does the dog's copy constructor, right? And then it prints out the right one for the wolf, for dog. The prints for the right one for the dog's copy constructor, for wolf, meow, and then mammal speak. So here the reason why 3 prints out wolf. Let's see. What is the reason why 3 prints out wolf? When you do 3, goes up here, it does a mammal, creates a new mammal, and goes up here, creates a new mammal, prints out mammals constructor, and then that's it. And then where does it print out wolf? Let me see. Where does it print out wolf? Okay, it does the speak in wolf. Okay, so after that, what did they do? They called speak. Okay, so they set they have an array of pointers, right? Mammal pointers, and they for each choice they set the array of pointer to point to whatever's the current one, right? So there are 3 mammal types, so they set for whatever's the current one. Then they loop through it and they call the speak for each one. Then they called another array that clones it, and then it calls the right speak for each one. So that's the reason why. Anyway, so that's the cost of virtual functions. Yeah, because object with virtual methods must contain a vtable, some overhead occurs having virtual methods. If you have a small class from which you do not expect to derive other classes, there might not be a reason to have any virtual methods at all. After you declare any methods virtual, you've paid a price of the vtable, although each entry does add a small amount of memory overhead. At that point, you might want the destructor to be virtual, and the assumption is that all other methods probably are virtual as well. Take a long, hard look at any non-virtual function and be certain you understand they are not virtual. So anyway, that was pretty much it. Rate, comment, subscribe. I'll check you guys later. Peace.